Okay, up until this point in time, we've been using trigonometry to find the measures of sides of right triangles. We've talked about how sine, cosine, and tangent are defined by the ratios of different sides of the right triangles. We could also use trigonometry to find measures of angles. So today's problem is to find the measure of angle L in the right triangle given below. So let's just go, with things we know. So we've got angle L, it's unknown. Sometimes when we have an unknown angle, we'll replace it, instead of a question mark or an X, we'll use theta. Okay, I'll write that up here. This is theta, it's just a Greek letter that we use often as a variable for an angle. So you'll see that sometimes, but we could also just use the angle L as well. So what do we know about angle L? Let's see, we know that the side opposite to angle L is 35, right? So we know that this is the opposite side, and we also know that the adjacent side is 65. Okay, so when I see opposite and adjacent, hopefully by now we're getting used to this SOHCAHTOA. When I see opposite and adjacent, I'm thinking tangent. So I know that the tangent of angle L, we could call it L or theta, we'll call it L for now. The tangent of angle L is equal to the ratio of the opposite side to the adjacent side. Okay, well that's great. But I want to know what angle L is. And I'm not really sure how to get there, okay? We often, think about undoing operations, right? We don't really right now have a way to undo tangent. Some of you might say, well, can we divide by tangent? Like, can I divide both sides by tangent? It's not a terrible thought, except that tangent by itself doesn't mean anything, right? The tangent and sine and cosine, those are actually, we call them functions or operators. So it needs an argument, it needs a number to operate on in order for it to mean something. It's kind of like, just like the square root symbol. The square root symbol doesn't mean anything if there's not a number underneath it. So we can't just divide both sides by tangent. It doesn't work that way. So let's just take a little bit of an aside and talk about something maybe you learned in 6th or 7th grade. Let's say, I'm just going to make up something, 2 times L, let's say 2 times L equals 35. I'm just going to make it a little bit of a simpler problem here, right? In this case, yes, we would divide both sides by 2 to isolate L, right? And get that L is equal to 35 divided by 2, which is 17 and a half. But what if it was like 2 plus L? Well, if it was 2 plus L equals 35, well, then I'd subtract 2 from both sides, right, to isolate L. Because the idea is I want to cancel out that 2 from both sides. Well, over here, we need a way to cancel out tangent. If you remember back in 6th or 7th grade, these were called inverse operations, right? Inverse operations undo each other, right? So addition and subtraction are inverse operations, multiplication and division are inverse operations, squaring and square rooting are inverse operations. So we need a new tool here. We need an inverse to the trigonometric operations. So the inverse trigonometric operations, they have special names. So inverse trig functions, we'll call them, are denoted by this. We go, the inverse of tangent is tangent, it looks like an exponent of -1. It's not an exponent. This is just the way we say inverse tangent. So this means inverse tangent. And likewise, sine inverse and cosine inverse, right? These mean inverse tangent, inverse sine, inverse cosine. So I can use this inverse tangent over here to undo what's happening over here. So I can do inverse tangent of the tangent of L. And if I do it to this side, I have to also do it to the other side. So I can take the inverse tangent of 35 over 65. So now this inverse tangent of the tangent, that's going to cancel the tangent, and I'm just going to be left with L over here. And I'm going to be left with L is equal to the inverse tangent of 35 over 65. Okay, well that's great, but it still doesn't tell me what the measure of angle L is. I mean, it does, but this is not something I'm familiar with. So at this point, I have to grab my calculator. And we'll see that my calculator here, we know has sine, cosine, and tangent on it. But if we look right above, we have inverse sine, we have inverse cosine, and we have inverse tangent. So these buttons are going to help us find the angle measures when we don't have them. But the first thing you're going to want to do before you even try to use sine, cosine, and tangent, hopefully you've already done this because we've been using these trig functions for a little while now, a couple days now, but we do want to double check that the mode of our calculator is in degree mode. Okay, so my calculator is in degree mode right now. If it's not, you're going to want to go over and highlight it. If you're using your phone as a calculator, you're going to want to look in the bottom left-hand corner. If you see the words RAD or DEG, those mean radian or degree mode. You do want to make sure that you're in degree mode. If you're not in degree mode, you'll get some pretty funky answers. Like you'll start to get like negative angles and things like that. So you definitely want to make sure that the answers are making sense. So we again have inverse tangent of 35 over 65. So we want to know what angle has a ratio, a tangent ratio of 35 over 65. So I'm going to choose second tangent, and that's going to give me my inverse function, 35 divided by 65, and I'm going to hit enter. And it tells me that the angle is about 28.3 degrees. So angle L is approximately 28.3 degrees. So just a quick note or a quick summary is something to remember is that trigonometric functions like sine, cosine, and tangent, we put in an angle and we get out a ratio. For example, if I put in my calculator the sine of 30, my calculator is going to tell me that the sine of 30 is 0.5. In other words, that the ratio of the opposite to the hypotenuse in a triangle that has a 30-degree angle, a right triangle that has a 30-degree angle, the ratio of the opposite to hypotenuse is 1 to 2, or 0.5. If I plug in the cosine of 63 in my calculator, the number it gives me is telling me the ratio of the adjacent to the hypotenuse in a right triangle that has an angle measure of 63 degrees. On the other hand, an inverse trigonometric function, I put in the side ratio and then it gives me the angle. So when I take the inverse sine of 1/2, that calculator is going to tell me that it's 30 degrees. So for the inverse trig, we put in the ratio, we get out the angle. For the regular trig function, we put in the angle, we get out the ratio. It's an important distinction. Let's just look at two more examples before we go. All right, so we're looking for the measure of angle I. Again, we'll replace that question mark with a theta, right? Because that's a better variable than a question mark, and we'll use it this time as well. All right, so let's think about, in terms of theta, what information do we have? Well, we have the side opposite theta. We know that that's 8, and we know this is the hypotenuse of my right triangle, so we know the hypotenuse is 10. So if I go back and I look at SOHCAHTOA, I remember that the ratio of the opposite to hypotenuse, that's the sine ratio. So that means the sine of theta, or the sine of angle I, is equal to 8 over 10. Which means that theta must be equal to the inverse sine of 8 over 10. So it looks like I skipped a step here. I didn't write that step where I did the inverse sine on both sides. That's up to you whether or not you include it or not. I included it the first time just to show you that I'm undoing the trigonometric function on one side and I have to balance on the other side. You can go straight to this step if you're comfortable enough, right? So the inverse sine of 8 over 10 is going to give me the angle measure. So that's where I go grab my calculator again, and I do second sine, so inverse sine of 8 over 10. And that tells me that the angle measure is about 53.13 degrees. So this angle is approximately 53.13 degrees. Okay, one more example. We're looking for, it looks like the measure of angle A here. So again, we can replace that with a theta. And relative to angle A, let's think about the sides that we have of our triangle. We have the 3 here, which is right next to angle A. So this is our adjacent side. And we have the 8, which is the hypotenuse of our triangle. So adjacent and hypotenuse, SOHCAHTOA, is going to be cosine the cosine of theta is equal to 3 over 8. So to undo that, again, I'll write the whole thing out this time. Inverse cosine of the cosine of theta. I've got to do it to both sides. Inverse cosine of 3 over 8. So again, the inverse cosine is going to undo the cosine. I'm just going to be left with cosine is equal to inverse cosine of 3 over 8. I'm going to grab my calculator, and it's going to tell me that the inverse oops, I'm in the wrong window. It's going to tell me that the inverse cosine of 3 over 8 is approximately 67.98 degrees. We could call that about 68 degrees. So theta is about 68 degrees. Okay, so we'll do some more practice with this in class, and then we're going to start using it to answer questions about right triangles and some applications about right triangles as well.